Okay, second part of this compression lesson is I'm going to show you a little technique. It's called ducking. It's using the sidechain facility of the compressor. And to describe ducking, the best way I can describe it really is when you listen to a radio station and a song is playing. When the DJ wants to speak over it, his fader comes up and the song goes down. So what it's doing, that when the fader comes up and his voice speaks, his voice is actually telling the compressor to turn down the volume of the music. Now that's ducking. Dance music has started using it. They've used it for a while now, but they've actually used it as a technique in sound design for a majority of the times in dance music. So I'm going to show you that technique now. And what I've done on track 1, we've got a simple kick drum beat that I've typed in using the MIDI keyboard. And the second track is actually something that I've typed in using the MIDI keyboard again, and it's a nasty sort of dance melody. Right, simple. Now what I've actually done is I've bussed the first track. I've set up a bus, go to sends, making sure my volume of my bus was being sent, and we put on to bus 1 sidechain. I've named it sidechain, and I've done that because on the second track, which is our melody, the dance music melody, I've actually put a compressor on it, and I'm using this time the limiter. I'm using the limiter because it's more harsh. Using full ratio is basically the limiter anyway, you know. I hate it when the little tail kicks up there, and I don't know why it does, but the limiter takes that down and limits the sound, hence the name. Now we've set this up because on our sidechain choice for you could have none, which means this wouldn't be sidechain. We'd be using the compressor in the traditional fashion, like in lesson 1. But we've going to set this up now so it's sidechain to our bus 1, our kick drum. Because what sidechaining is basically using a different input signal to talk to the compressor. So when this kick drum signal comes in, it tells the compressor to work, like so. I'll not bypass off now, we'll only hear the kick drum, and you can see by here the effect it's having over the kick drum. It's not having an effect on the kick drum signal because the compressor is actually on the melody channel, but it's getting its information of when to compress from the kick drum. Now this sidechaining and ducking comes because this is going to actually affect this channel's signal. So every time this kick drum beats, it's going to tell the compressor to compress this channel signal, like so. Bypassing it, obviously it's as normal. Yeah, that's been used quite a lot in sort of pop dancey music over the last few years, and it gives it a sort of like that sucking sound. And that second sound is being controlled by the dominant beat, which is the kick drum, so it stays in time with that beat. And I've used, like I said, I've used the limiter there, but using the ratio this harshly with the neither abruptly is basically using the limiter anyway. There would be no difference changing from the limiter to the compression, and I'll show a little example of that now. You can change it about a bit, take the gain down a little. The difference between, again, the peak, when I said I'll show a little example of that now, the RMS, which root mean square, which takes sort of on a sort of like the average amplitude of the audio signal, comparatively to the peak, which takes off as soon as that transient reaches the decibel that we've created with the threshold. I'll show you the difference in it. That's the RMS is the average, and the peak is more instant. I'll show that. So it's sort of slower. So look at the different circuit types. And that's basically side chaining, ducking using the side chain. Okay, thank you.